Hi guys, my name is Terry. In this video, I'm going to go through with you Additional Mathematics Form 5 at Maths textbook for Chapter 1 Circular Measure Formative Exercise 1.4. So if you enjoy this video, kindly like, subscribe, and leave us a comment. So let's get straight to the first question. So here we have a cylindrical cake, radius of 11, height of 8. As you can see from the diagram, the angle subtended POQ is 40 degrees. So we are supposed to calculate the perimeter of sector POQ. So first part, let me just redraw the sector for you once again. So it looks like this. This is POQ and the radius is 11. This angle here is 40 degrees. So what we need to do, number one, to find the perimeter, we need to find the length of arc, and then you add the two radius. So now normally what I will do is I will take s equals r theta. I will calculate radius 11 and I'll multiply with theta 40 times pi over 180. Then I plus the length of two sides, 11 times 2 or 2 times 11, and my answer is 29.68. Yeah? Perimeter means the length of all sides here add together. But what I've discovered is that when you compare your answer, some answer, not all the answers, right, with the textbook at the back, right, sometimes there is a difference in the answer because the textbook tend to convert the angle theta to radian in advance, and they tend to round off correct to 3 decimal places. But actually, for accuracy, it's better to use 4 significant figure for everything, right? But the textbook uses 0.698, yeah, to 3 decimal places. Sometimes the answer is the same, sometimes you might get a difference, a slight difference in the answer. Okay, so let's move on to part B, area of sector. Okay, so for example, in B, if you use area of sector as half r squared, 11 squared, theta is 40, I times pi over 180. Now I would get 42.24. Yeah, but if you use 0.698, you will get 42.23. This is from textbook. Yeah, answer given at the back. So that's because the textbook uses uh, theta correct to 3 decimal places and then they sub it in, right? That's why you can see there's a difference. Okay, all right, but remember we still use pi as 3.142 throughout the calculation. We always use pi as 3.12. That is required in the exam. Okay, let's look at Roman 3. The volume of a piece of cake that has been cut up. Okay, now we know volume of a prism can be any shape as long as you have a uniform cross section. You multiply with the length. Okay, this is A, this is your H, your volume is V equals to A times H. Now in this case, your A is your area, cross section area, which you have got earlier. Okay, if you want to get the same answer as textbook, then you should use 0.698, and then you should get 42.23 here, and you can use 42.23 and then you multiply with um, the length or the height of your cake, which is 8, and I think you will get 337.4. Okay, so here's the thing that I quite, should I say, disagree. You see, there is no point giving up to 5 decimal point at the end if you have, 5 significant figure at the end. If the first part you messed up, we use 3 decimal places, right? You should be using 4 significant figure at every step of the way, so your answer is more accurate. Yeah. If you messed up in front, what's the point of having high accuracy at the back, right? So yeah, that's what I think. Yeah. Okay. Now let's look at the next one. The mass of a slice of cake that has been cut out is 150. Calculate the mass of the whole cake. Okay, actually this question has nothing to do with part A at all. Yeah. Because we know if the cake has angle of 40 degrees here, so I can draw a circle. That means you divide each slice to 40. The question is, how many slices will you have, right? So we take 360 divided by 40. So we know this cake will have 9 slices, right? So one slice will have mass of 150 gram. So the whole cake the total mass will have 9 slices. So 9 times 150 gives us 1350 gram. Okay, so correct. That is for question number 1. Okay, let's move on to question number 2. Okay, so diagram shows the plan of a swimming pool, all right, with a uniform depth of 1.5 meter. ABCD is a rectangle. The length 12 meter, width is 8 meter. Yeah, BEC are two sectors. Okay, so now what we can do, I hope this thing is clear. I can just draw from here. I would extend this line over here. I know this will be 6. I would extend this line over here. This will be 4. Half of 8 is 4, half of 12 is 6. So what we have here is a right angle triangle. Can you see? And to find the whole thing, okay, I'm actually finding angle BEC. In order to find the perimeter, of course, we need to find the length of arc BC. But before we find the length of BC, we need to find the angle theta, which is BEC. So I'm going to draw a right angle triangle there, as you can see. The opposite is 4, the adjacent is 6, so we should use tangent, right? So we have to use SOHCAHTOA, trigonometry. Tangent theta over 2 is now 4 over 6. Now please use your calculator. Remember, change your calculator to radian mode so that you will get your answer instantly in radian. So but be sure you have to times 2. This is 2 times of 10 inverse 4 over 6, which gives us 1.176 radian. Okay, now to find the perimeter, we need to first find the length of this arc. Okay, and then you times 2. Then you add the length of these two sides, 12 and 12. So I'm just going to write this as PP, sense of perimeter. Your length of arc, so 2 times of length of arc is S equals R theta, my R radius. Oh, I need to find my radius first. Oops, my radius, we can use Pythagoras theorem to find it. That is the length of EB, this length here. We will write EB, or the radius, as 6 square plus 4 square square root. 36 plus 16 gives us square root 52. Yeah, you can leave it at square root 52, but again, because if you want to match your answer with the textbook, right, they will they tend to round it off first, right? But you can use square root 52. Actually, to be more accurate, we use square root 52. But if not, you want to use 7.211, round off also can, right? To at least 4 significant figure. Now, your perimeter is therefore S equals R theta times 2. So 2 times of your radius is 7.211. The theta is 1.176 plus 2 times 12, right? You add them up, your answer is 40.96 meter. Sorry, this length is in meter, not in cm. 7.211 meter. All right, so I've got my perimeter. Next, I need to find the area of the floor of the swimming pool. So some people, they would go in, how do I say, they will go and use area segment. You can, I actually thought in the previous video I taught how to use segment, but I think we don't have to minus segment, just have to look at it as a sector like this plus a triangle like this. These two are identical, plus an identical sector, congruent sector on the other side, right? So we just add them up. We'll do this way. So the area of sector is half r square theta. My radius is 7.211 square. My theta is 1.176, right? That is to find one sector, but I need to times 2 because I have 2 of them. Then I add the triangle. Now this triangle, you can see, if you can see, the height here is actually 4, right? So we can just use half times 12 times 4, yeah? Half times base times height, half times base times height times 2 to get this triangle, right? And then use your calculator, add them up. You should get 1 109.15. Okay, just so you know, your textbook give us more decimal point. I think the textbook answer is 109.156, right? There might be a slight difference in answer because if you use square root 52 here versus if you use 7.211, there is a slight difference in answer, but I think it's okay, right? So just so you know, my answer here using this is 109.15. The textbook uses 109.156. Okay, all right, that is part B. Part C, volume of water needed to fill the swimming pool. Okay, very simple. Like I said, a swimming pool is actually a form of a prism. It's a uniform cross section. In this case, your cross section area is this whole thing here. Oops. You multiply with the depth of your swimming pool, which is 1.5 meter. So we'll just take the volume here, 109.15 times 1.5. All right, you will get 163.725. You can round up, but round up to 73 if you want, right? Normally, I would prefer to round up correct to 4 significant figure, but this is 6 significant figure. I think the textbook answer gave us 163.734. Yeah, that is because the previous area is different. Previous area is 109.156 from the textbook. So I think a slight difference answer is okay, right? That's because again, whether you use what do you call that, square root 52 or 7.211 from for the radius. Okay. All right. Let's look at the next question. Question number 3. So diagram shows a cross section area of a tree trunk with a radius of 46. It's floating on the water. So point P and Q lie on the surface of the water while the highest point R is 10 cm above the surface. Okay, now perhaps, should I redraw for you? Let me redraw just this part here. Okay, now you can see that the radius here is 46. And if this top part is 10 cm, so the length from here to here, it will be 46 minus 10, which is 36. Now it's important that you find the length of two sides. Yeah, every time you do not know the angle, and you're not given the length of arc, you can use trigonometry. To use trigonometry, we need a right angle triangle. So to create a right angle triangle, now we can do that because this is a radius. Radius, these two are equal length. These two are equal length, so it's isosceles. We can divide evenly at the center and get a right angle triangle. So now I know I need to find angle BOQ first, right? Which is my theta. I have it. This will be theta over 2. So we have to use cos. Why cos? Cos is adjacent over hypotenuse. Yeah, 36 is your adjacent, 46 is your hypotenuse. So you want to use your calculator in radian mode. 2 times of cos inverse 36 over 46, right? And you should get 1.344 radian. Okay, correct before SF. Yep, that's your answer. Okay, next one. Find the length of arc BRQ, which is the arc on top here, BRQ. So very simple, we just use S equals R theta. My length of arc is, radius is 46, theta is 1.344. Use your calculator, you will get 61.824. Yeah. All right. Part C. We want to find the cross-section area that's above the water. That means cross-section area, we're talking about this area of segment. All right. Now, in the past, and I think in the previous video, I've explained to you guys that to calculate area of segment, we can use a shortcut formula: area of sector minus area of triangle, right? So if you follow my previous video, so we can just use half r square theta minus sine theta. I just factorize directly. Yeah, it's half r square theta minus half r square sine theta from half AB sine C. You factorize together, you get this. So if you use this, it's actually a shorter way, but sometimes your answer might be a little bit different because due to the different method that we use. So my radius is 46, my theta is 1.344, you minus sine 1.344. But be careful when you use this formula, your calculator must be in radian mode because this is sine 1.344 radian, not degree. So if your calculator is in degree mode, then it will give you a different answer altogether, right? So this method will give us this answer, 391.069. Okay, the textbook gives us 391.068. Slightly different, right? Maybe due to the this answer, give us 391.046. Yeah, sorry, I looked at the wrong one, 46. All right, the textbook gave us 068. Okay, I guess because the textbook split this into two, right? Since we know this is 46, we know this is 36, they find this length first, which I find is a bit longer. Not necessarily more accurate, just so you know, it's not necessarily better. It's just that is one more way, finding the height of the triangle, which we can say that the height here, x, yeah, let me write over here using Pythagoras, it will be 46 square minus 36 square square root, which gives us square root 820. So you can use this method though. This is area of sector, half r square theta. Then you use area of triangle, which is half times base times height. But take note that this is only half of it. We're taking this triangle, so you go to times 2. So it's 2 times of half times base. My base is square root 820. The height is 36. You should get 391.069. Okay. Again, the textbook got 68. Perhaps because they round off the square root 380, 820 to decimal, and then they sub in. Maybe that's why the answer is slightly different. Okay, you don't need to worry so much about the final answer here because sometimes it's just a matter of accuracy. This is like 6 significant figure. Obviously, it's going to be hard to achieve the same answer, right? If you're talking about 4 significant figure, yeah, it'll be almost the same, right? Let's look at question number 4. Okay, this question is very interesting, but I may have problem with space. The question itself is too. I need a lot of space. All right, diagram on the right shows the logo of an ice cream company. The logo is made of 3 identical sectors: AOB, COD, UF. Right, from a circle with center O and radius of 30. Yeah. Okay, they're all 60 degree. So now they're all 60 degree here, 60, 60, and 60. All right, calculate the length of arc AB. Okay, the first part, very simple. Perhaps I can squeeze this. Okay, never mind. I'll just write here. Okay, length of arc AB is r theta. Your radius is 30. Your theta is 60. Okay, again, the textbook, just to make your life easier, like all your answers be the same as textbook, we'll just round off your theta to 60 times pi over 180. Please use 3.142 and you will get 1.047. Okay, just to make it the same as your answer from the textbook. So theta is 1.047. Multiply inside, you should get 31.41. Okay. All right. Next one, area of sector. Now your area of sector COD will be half r squared theta, 1.047. Okay, I'm using the same value of theta earlier. You will get 471.15. Yeah, 471.15. Sorry, it is a bit ugly. Okay, let me fix this. Okay, next, I'm finding the perimeter of segment EF. Segment EF. Okay, now to find segment, right, I can see that this is 30. Doesn't matter which part, they're all the same, but these 3 are identical. So your length of EF is also 30. Why? Because it's equilateral. When you have equilateral triangle, the length are all the same. Yeah, all 3 sides have the same length, right? Okay, Um, so I basically just have to take this length and add to the length of arc. Sorry for the ugliness. Yeah, better don't scribble like that. So your perimeter will be just 30 plus the length of arc 31.41. Okay, let me move out a bit. Okay, perhaps I just move it over to the other side so that you got more space to see. Okay, this one I'll just move over to this side. So your perimeter is just length of arc 30, radius 30 plus length of arc 31.41. I got 61.41. Okay, simple. All right. Next, I want to find the area of segment EF. Okay, I like to use half r squared theta minus sin theta because I think it's faster. Yeah, but you can choose half times base times height. So let me just show you my method. Half r squared. My r is 30 square. Theta is 1.047 minus sine 1.047. So this formula for area segment is the fastest to calculate. Yeah, and my answer is 81.48. Okay, but there will be slight difference between this and the textbook method. I think because the textbook they divide this evenly at the center. So for example, if you want to find this segment, right, we can divide this evenly here. We find the height because we don't know the height. We know, let's say this want to call this EF, can I call this G? We know FG will be 15. Half of 30 is 15, right? So to find the height of your triangle, we need to use Pythagoras. So let's say the height here is 30 square minus 15 square root, which gives us square root. Sorry, it is 30 square minus minus 15 square 675. 675. And with that, we'll take area. I put the or here as half r square theta minus half times base times height. Now my base is now 30 here because your base is measured from here to here, f to e all the way here, and your height is square root 675. Now if you were to use this method, then your answer is 81.44. Yeah, which is exactly the same as the one given textbook. Okay, let me move out a bit. This will be 81.44. Okay, so this is the textbook's answer because they use this. Is it more accurate? I don't know. Now let's look at the next one. B. The logo is casted in cement. The thickness is uniform and is 5 cm. So find the amount of cement needed. Okay, so amount of cement is basically the volume, right? The area, right? Then you multiply with the length to get the volume. But we have three parts of it. We have three sector here. So okay, let's see. I will start off by taking the volume as 3 times. Okay, maybe I would say, okay, I'll just take 3 times cross section area, which is 471.15 multiplied with the depth of your logo, which is what? The thickness of the depth, 5. Okay, now use your calculator. You should get 7067.25. Okay, and lastly, they say the cost of cement is 50 cents per cm cube. Calculate the total cost. Okay, this is simple. We know the volume of cement required is 7067.25. You multiply with 50 cents. Alright, you will get Rm 3533.63. Alright, that is number 4. Okay, that's the end of this video presentation. Yep. Well, if you're interested in more of our workbook, we have notes, tutorial, topical practice, past year question, past year practice, and so on. Right? Yeah, get in touch with us. Yeah, you can even join our class and find us from Shopee as well. Thank you for watching. Yeah, I'll see you in the next video.